Hello, Data Standard community. I'm your host, Shayna Weldon, and this is the Data Standard audio experience. We have a very exciting guest today. On our podcast, we have Daniel Deychakiwsky, a senior machine learning engineer at Spotify. He is passionate about solving real-world problems with artificial intelligence, and today we are speaking about data extraction. Welcome to the show.
Hey, thanks for having me. Appreciate it.
Thank you for being here. Just to start off, can you please go ahead and just introduce yourself?
Yeah, my name is Daniel Deychakiwsky, and my current role is senior machine learning engineer at Spotify. You pretty much nailed it with your opening.
Well, thank you. So how did you first become involved in artificial intelligence? What brought you here?
Man, it almost seems like I was sort of pulled into it, to be honest with you. But I started out my career in web development, and I remember I attended like a seminar, and there was an engineering group that was giving a presentation on their latest and greatest kind of like regression modeling approach. And the way they were able to just fit like a sinusoidal time series of revenue data, I was pulled into it. I thought it was the coolest thing ever. And I set up meetings with those engineers, and they sort of explained how all of that stuff works at a very general level. And I couldn't stop thinking about it. So I ended up like buying books on the topic and teaching myself a good amount. And then because I was always like learning and reading all these books on the topic, I said, hey, I might as well see if I can pursue something more official on the topic. So I ended up enrolling into a master's program through Georgia Tech, and I did that for 2 years while working and, just teaching myself and staying up to date. And it's been a wild ride, but a great experience. That's how I got into it.
Oh, that's very impressive. So now you're the senior machine learning engineer at Spotify. What exactly does that entail? What do you do?
Well, we wear many different hats. We're responsible for, writing data pipelines to process large scale data. We're responsible for visualizing data, for modeling data, for evaluating our models, for deploying our models, A/B testing two models against each other, staying on top of the field. So like research, going to conferences, reading books, taking courses, teaching others, improving products, and more. Honestly, there's probably some things that I'm not remembering right now, but we wear many different hats, and we get to be involved in, I guess what you could say is like the entire machine learning development lifecycle, like from the data to, the shipped product. And we get to iterate on all that.
Okay, that sounds very interesting. And then going off of machine learning, I know it's powered by data. It has to be processed at a certain scale. So how do you process large scale data at Spotify?
Yes, data is everything. There's like this saying, garbage in, garbage out for machine learning models, right? So data powers all of it. It's like the oil for a car, or I don't know. They're using like electricity metaphors nowadays, but I like the oil and car one. Just sticks with me. But yeah, so I mean, the way we do it at Spotify is we use, for the most part, something called Shio, which is a tool that we've open sourced. It's a Scala wrapper for Apache Beam. And what that lets you do is engineers can write their business logic pipelines and essentially not have to worry about the whole distributing the computing. So there's a lot of work that has to go into, writing the logic to have like many different workers communicate with each other. So actually, let me back up. Let me just say what distributed computing is for people that don't know. So if you have a bunch of data and you need to go through it, and by a bunch I mean like a lot. You could try and parallelize it. So the current computer I have here sitting on my desk has like, I don't know, 8 cores in it or something like that, if I had to guess. So maybe it can do like 8 different things at the same time or more. But the point being that the computer can process multiple things at the same time. So you can sort of distribute that work. And when you're dealing with the amount of data that we deal with on a daily basis, it's like you want to take advantage of that, but you also want to take advantage of that and distribute it over multiple computers. So it's as if I had this, I have a MacBook here. It's like I had a MacBook and then another one next to it and then another one next to it. And, potentially they were even bigger, like they had more memory and more processors. So how can I distribute all this data processing I have efficiently over all those computers and all those processors to parallelize it? And that's sort of what Apache Beam has enabled the community to do. And we just so happen to have written a Scala wrapper, which means that engineers at Spotify can write their, data processing logic in a programming language called Scala, and they can submit it to different like runners, Dataflow, Google's Dataflow, et cetera, cloud computing software. We could take advantage of like large scale compute resources. So that's pretty much how we do data processing. And then there's some other stuff that goes into it. Like, a lot of times you have to orchestrate your data pipelines. You have to connect your input sources to your data pipeline. And you sort of have to like make sure that your input data sources are available and there. Also, when you write out your data to your output source, it's possible that you could have downstream consumers. So people that ingest your data that are waiting for your data. So you sort of have to like orchestrate and hook that all up. And we have a tool called Luigi for that, which is a Python orchestration framework. And we use that to orchestrate. And that's also open source and available as well. So those are probably the two main things I would say for writing massively scalable distributed jobs.
Oh, all right. No, great explanation. And then how is that data used within your machine learning tools?
Yeah, so that data that we generate, often we'll clean the data, we'll transform it in a certain way, we'll analyze it, et cetera. And, once we have data sort of materialized to a certain consumable materialization, if you would, we'll bring that into our models and we'll train our models on certain features that we pull out from that data. And we also do like some feature sharing stuff, which I think we can get into later. But yeah, so this data is, we write these massively scalable jobs to compute certain data points that we think will be useful for solving a business problem. And we use them as inputs to our machine learning models, and our machine learning models learn off this data, and we evaluate them from there and ship them out if all goes well.
Okay. And I know you mentioned or briefly talked about feature sharing. So diving into that, what exactly is feature sharing? Feature sharing
is important stuff. It's cool. So if you think about it, and there's a lot of companies that are now shipping literally like feature stores, like you see it in the news. I forget what they're called, but you're seeing these large valuations and stuff like that because it's a very valuable thing. And the reason for it being is, for example, like if you can think of, like imagine a scenario where there's two teams and let's just say they're pretty separated across the organization. So they're not like really communicating on a daily basis, right? But let's just say they're both AI teams, they're both training models. So they're both materializing data, like they're reading some sort of data and they're both calculating a feature. But in this situation, what if they're both calculating the same feature? So they're, using compute resources and it could be expensive. I mean, maybe this data point isn't, but maybe the other data point is, and they're doing this on a daily basis. But the feature sharing resolution here is that if there was a centralized store to sort of store these features, version them, and make them publicly available, maybe put a search tool on top of it, then these teams could just check that first and use it instead of, doing duplicate work. So it's in a way, you're sort of being more efficient across the org. It's like an aspect of discovery. So say one team is looking for a certain feature and another team's looking for another feature. Well, there may be other features, so like other data points that would be very useful to another team that this team wouldn't have necessarily known about if they wouldn't have, looked through what other teams are materializing. So with those two things combined, it sort of helps make the org more efficient and also helps the org kind of grow together.
Okay. And then how is audio used within machine learning models?
Audio is a super fun one. I would say for the most part, it requires a little bit of DSP knowledge, digital signal processing. But, to anyone listening to this, you can just take a Coursera course, take 2 Coursera courses on digital signal processing, read a book, read some blogs online. You'll get the bottom line for it. But the most common input for a machine learning model that I know of is an audio spectrogram, which is the result of something called a short time Fourier transform. I know it sounds so complicated and crazy, but it's actually quite simple. It's just like a 3-dimensional tensor, like a tensor block. You can think of it that way, or a 3-dimensional representation of audio. And you kind of think of it as like a picture. as an image of time on the x-axis and frequency on the y-axis. And then, if you were to color code it, you could color code it and show like amplitudes, like how strong the signal is in the third dimension, or like kind of what you would be seeing as, dark or light regions in the image. And so based on that, you can push that through various models. I mean, you could push it through something called a convolutional neural network, and it can extract information from various localized regions. And you can compress it, and you can do all sorts of, fun like audio fingerprinting stuff. Like I remember back in the day, the coolest audio program was at one point Shazam. Like how cool would it be if you were just at a bar, you hear a song playing, who knows, you're out shopping somewhere at a mall, whatever, you hear a song playing, you can lift your phone up and your phone will tell you exactly what that song is. So like audio fingerprinting technology at its finest. So there's a lot of really cool stuff you can do with audio. Of course, like applying sequence models. In that case, you maybe could try, representing audio in a different way or compressing it a little bit and then piping it through some sequence model, et cetera, et cetera. But yeah, most common is to transform the audio into something called a Mel spectrogram, which is sort of like a human perceived version of audio in a picture, in an image.
Wow. No, that's a great explanation. I'm learning a lot too by listening to you. So thanks.
I'm learning listening to myself too.
I know also you mentioned a blog, and I was going to say, do you want to talk about your blog a little bit?
Yeah, definitely. I mean, I have a blog. Things that are interesting to me, I write them down. Honestly, the reason why I do it is to like solidify information in my own head, because a lot of times I think one of the greatest proponents to like learning something is to reproduce it yourself. Like, actors, for instance, when they have to like read their lines, they will literally read their lines, X number of times, and then they'll try and reproduce it back in their own head. Or can you explain this concept? And if you can like reproduce it yourself, I think it's a good signal for that, you've actually learned the information, like your brain has encoded this information, it can reproduce it. So by writing blog posts, it's like a little bit of a selfish thing, as in like, I'm also like kind of trying to solidify things in my own head, but also, you're sharing information, and, the amount of information I've picked up from other blogs, I'm so grateful. So I think blogs are cool.
Me too. So moving forward, though, how do you evaluate ethical fairness in models when dealing with different demographics?
Yeah, I'll answer this kind of more generally speaking. There's a big wave this is so great, for responsible AI. So like model interpretability, per se, and also like fairness. And it really does all come back to the data, in my opinion, because although like machines themselves may not be biased, we humans are the ones training the AI models. So we're giving these AI models data, and us humans are biased for sure. Like there's no way getting around that. Like no one is bias free, in my opinion. So it all comes back to the data, and there are many different things you can do to like identify data bias, feature bias, label bias. But if you could imagine like training a model on, I don't know, let's just say a certain type of cat or something, and you only give the model examples to learn from based on, I don't know, let's say like an alley cat. One type of cat. I don't know cats. I'm a dog person, but you give the model only certain types of cats, right? And then you ask the model later on to give you prediction based off a different cat. Well, that model is not going to know anything, but anything. It's not how, the question is, how well is it going to be able to generalize to that new cat, given that it's only been trained, it's only learned from, a distribution of a certain type of cat. So that's kind of what it boils down to. Unfortunately, there are so many different ways that bias can sneak into data. It may not be something as obvious as, you're working with some kind of, gender, so, one of those types of features, but bias can be encoded in very sneaky ways into other features, like, even like maybe something like a zip code, or I don't know, I'm just coming up with examples off the top of my head, but you have to be very cognizant of the data you're using and how bias can sneak in there. And I mean, I think another like good example is like label bias. So, if you're getting machine learning, if you're getting your labels, you're training like a supervised machine learning model, which means that you're literally providing examples to the AI model and you're telling it, yes or no. Like you're giving it a label. Let's just say at the most basic case, like a binary label. Well, who's actually doing the labeling? Is it a human that's doing the labeling? Because if it is, then right there, you already know there's probably some bias happening, right? There's subjectivity potentially, so these Again, it's all about the data. It's all about making sure that you can visualize the data, cut it up in different ways, and then look at the distributions and ask yourself, how can bias sneak in here? Run various analyses on visualizing data cut up in different ways. So like, look at your label cut up by this feature, look at your label distribution cut up by that feature, et cetera, et cetera. And yeah, I think that's pretty much what I would say there.
Oh, that was good. And then just so you know, we at the Data Standard are building a community of data enthusiasts and data thought leaders where everyone's open to connect and collaborate with each other. So what can our community specifically do for you?
I just think that sharing information and decentralizing knowledge is the way to go. I think if we continue to do that, it's probably the best way forward for us to teach each other about not only our successes, but more importantly about our failures, because I think that learning from failing and failing fast is a super important concept so that other people can learn from all sorts of different signal. So yeah, write blogs, continue learning, continue being hungry to learn new information, and let's make the world a better place,
What a great note to end it on. That's right. Make the world a better place. And I like what you said, hungry to learn. Yeah, I like that. So thanks. And for more information on the Data Standard, you can find us at www.datastandard.io. And this episode was sponsored by Pandio, and they're innovating the tech space, and you can learn more about their work at pandio.com. But once again, Daniel, thank you so much again for joining us.
Thanks so much. It's been great.